Namaste my dear students, Nenu Mi Suryateja from Saimedha Ecet Coaching Center Koti, Hyderabad. Director JC Sir Advaryamlo, Shashikanth VALMIKI Sir Parvekshana Nirvahistuna Saimedha Coaching Center Koti, Hyderabad. Ecet 2023 రాసిన విద్యార్థులందరికీ మీరు అబ్జెక్షన్స్ పెట్టుకోనికి వీలుగా ఉండాలి అనే ఉద్దేశంతో ఈసెట్ పేపర్స్ అన్నిటిని బిట్ టు బిట్ ఎక్స్ప్లెయిన్ చేయడానికి ఈ వీడియో లెక్చర్ సిరీస్ మీ ముందుకు తీసుకురావడం జరిగింది. కాబట్టి మై డియర్ స్టూడెంట్స్, ఎవరైతే ఈసెట్ 2023 రాశారో, ఎవరైతే క్వశ్చన్స్ కి ఆన్సర్స్ తెలుసుకోవాలనుకుంటున్నారో, పూర్తి డీటెయిల్ ఎక్స్ప్లెనేషన్ ఈ వీడియో లెక్చర్స్ ఖచ్చితంగా వాచ్ చేయండి. అలాగే మీ ఫ్రెండ్స్ అందరికీ కూడా ఈ వీడియో లెక్చర్ సిరీస్ ని షేర్ చేయండి. దీంతో పాటుగా మై డియర్ స్టూడెంట్స్, ఎవరైతే ఈసెట్ 2023 రాశారో వీళ్ళందరికీ సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఒక ద్రోణాచార్య బ్యాచ్ ని ఇంట్రడ్యూస్ చేసింది. గత 25 సంవత్సరాలుగా ఎంతో మంది ఇంజనీర్లు తయారు చేసిన సంస్థ సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ డిప్లొమా విద్యార్థులకి అండగా బాసటగా నిలవన ఉద్దేశంతో ఈ బ్యాచ్ ని మీ ముందుకు తీసుకురావడం జరిగింది. ఈ బ్యాచ్ లో భాగంగా మీ అందరికీ మొదటిగా మీరు బీటెక్ లోకి వెళ్ళిన వెంటనే ఇబ్బంది పడుతారు అనే ఉద్దేశంతో, ఆ ఇబ్బందిని పోగొడితేనే ఫ్రీ మైండ్ తో ఉంటేనే పని బాగా చేస్తారు ఉద్దేశంతో బీటెక్ 2-1 అకాడమిక్ సబ్జెక్ట్స్ ని ప్రొవైడ్ చేస్తున్నాం. బీటెక్ 2-1 అకాడమిక్ సబ్జెక్ట్సే కాకుండా సిఆర్టీ క్యాంపస్ రిక్రూట్మెంట్ ట్రైనింగ్, దీనిలో భాగంగా ఆప్టిట్యూడ్, రీజనింగ్, ఇంగ్లీష్, అదేవిధంగా సిఆర్టీకి కావాల్సిన బేసిక్ కోడింగ్ లాంగ్వేజెస్ సి కావచ్చు, C++ కావచ్చు, జావా కావచ్చు, పైథాన్ కావచ్చు, వీటన్నిటిని మనము లైవ్ క్లాసెస్ ద్వారా అందిస్తాం. దీంతో పాటుగా థర్డ్ వన్ డిప్లొమా బేస్డ్ జాబ్స్ టెస్ట్ సిరీస్, మీరందరూ సంవత్సరం నుంచి కావచ్చు, సెకండ్ ఇయర్ కంప్లీట్ అయిన దగ్గర కావచ్చు, ఫస్ట్ ఇయర్ కంప్లీట్ అయిన దగ్గర కావచ్చు, ఈ సెట్ కొరకు ఇంజనీరింగ్ సబ్జెక్ట్స్ బాగా ప్రిపేర్ అయ్యారు. ఇదే ఇంజనీరింగ్ సబ్జెక్ట్స్ అనేది మీకు రేపు డిప్లొమా బేస్డ్ జాబ్స్ కూడా ఉండడం జరుగుతుంది. కాకపోతే మీరు రేపు జాబ్ పడినప్పుడు రెడీగా ఉండాలంటే కన్సిస్టెంట్గా ప్రిపరేషన్ అది అవసరం అవడం జరుగుతుంది. కన్సిస్టెంట్గా మీరు ఆల్రెడీ మీ అందరూ బాగా ప్రిపేర్ అయ్యారు, మీకు సపోర్ట్ ఉండాలనే ఉద్దేశంతో ఒక టెస్ట్ సిరీస్ కూడా మనం ద్రోణాచార్య బ్యాచ్లో ఇంక్లూడ్ చేయడం జరిగింది. ఈ టెస్ట్ సిరీస్లో భాగంగా ప్రతి వీక్ టాపిక్ వైజ్ గ్రాండ్ టెస్ట్లు కండక్ట్ చేస్తాం. టాపిక్ వైజ్ అయిపోయిన తర్వాత మనం మిక్స్డ్ టాపిక్స్ ఆర్ మిక్స్డ్ సబ్జెక్ట్స్ గ్రాండ్ టెస్ట్ కండక్ట్ చేస్తాం. ఫైనల్ గా ఓవరాల్ గ్రాండ్ టెస్ట్లు కండక్ట్ చేయడం జరుగుతుంది. 1 ఇయర్ పాటుగా మీకు ఈ డిప్లొమా బేస్డ్ జాబ్స్ యొక్క టెస్ట్ సిరీస్ కోర్స్ అందించడం జరుగుతుంది. దీంతో పాటుగా 2 ఇయర్స్ వ్యాలిడిటీతో ఆల్ ఓవర్ ఇండియాలో ఎవరు తయారు చేయలేని విధంగా మన సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఒక గేట్ కోర్స్ని రెడీ చేయడం జరిగింది. ఆ గేట్ కోర్స్ విత్ వ్యాలిడిటీ ఆఫ్ 2 ఇయర్స్ అందించడం జరుగుతుంది. ఈ 4 మాడ్యూల్స్ మనము ద్రోణాచార్య బ్యాచ్లో అందించడం జరుగుతుంది. దీని విలువ సుమారుగా ₹1,00,000. కానీ ఈ కోర్సు మొత్తాన్ని ఫ్రీ ఆఫ్ కాస్ట్గా అందించడం జరుగుతుంది. జస్ట్ ఈ 2 సంవత్సరాల మెయింటెనెన్స్కి, అదేవిధంగా టెస్ట్ సిరీస్ కోసమని రిజిస్ట్రేషన్ ఫీజ్ ₹3,000 అనేది తీసుకోవడం జరుగుతుంది. ఎవరైతే డిప్లొమా కంప్లీట్ చేసుకుని బీటెక్ వెళ్తున్నారో వీళ్ళందరికీ ఒక మంచి అవకాశం ఇది. కాబట్టి ఈ అవకాశాన్ని మీరందరూ ఉపయోగించుకుంటారని ఆశిస్తున్నా. మీరు ఈ అవకాశాన్ని వినియోగించుకోవాలంటే ముందుగా మీరు మన అప్లికేషన్ స్పేస్ గేట్ అనే అప్లికేషన్ని డౌన్లోడ్ చేయండి. డౌన్లోడ్ చేసిన తర్వాత అందులో ప్రొఫైల్ సెక్షన్ ఉంటుంది. ఆ ప్రొఫైల్ సెక్షన్ మొత్తాన్ని ఫిల్ చేయండి. ఫిల్ చేసిన తర్వాత మీ అడ్మిషన్ ప్రాసెస్ కోసమని 9848692598 9848692598 ఈ నెంబర్కి కాంటాక్ట్ అవ్వండి. అడ్మిషన్ ప్రాసెస్ ఎట్లా, అదేవిధంగా ఇంకేమైనా కోర్స్ డీటెయిల్స్ ఏమైనా కావాలంటే కూడా పూర్తి ఇన్ఫర్మేషన్ అందించడం జరుగుతుంది. మై డియర్ స్టూడెంట్స్, మీరందరూ ఈ అవకాశాన్ని వినియోగించుకుంటారని ఆశిస్తూ నేను మీ సూర్యతేజ ఫ్రమ్ సాయిమేధ ఈసెట్ కోచింగ్ సెంటర్ కోటి హైదరాబాద్.
How many electrons in an atom may have the quantum numbers n is equal to 4? See, if small n means the principal quantum number, so for principal quantum number n is equal to 4, there will be 4 subshells: 4s, 4p, 4d, 4f. There will be 4s, 4p, 4d, 4f. In 4s subshell, there will be only 1 orbital. In 4p, there will be 3 orbitals. In 4d, there will be 5 orbitals. 1, 2, 3, 4, 5. So in 4f subshell, the number of orbitals would be 1, 2, 3, 4, 5, 7 orbitals. See, for all these electrons, see if electrons enter into these orbitals, for all these electrons, n is equal to 4 only. And he has already provided the spin quantum number m is equal to minus half. M is equal to minus half means m equal to minus half means anti-clockwise electron. So this one, anti-clockwise electron, anti-clockwise electron, so which is mentioned. So we know pretty well, in each orbital there will be accommodation for one clockwise electron and one anti-clockwise electron. So that here for how many electrons will contain spin quantum number as minus 1 by 2 means how many anti-clockwise electrons are there means here. So here these are anti-clockwise electrons, right? How many anti-clock? So in each orbital there will be one anti-clockwise electron. So how many electrons contain the quantum numbers as n is equal to 4 and spin quantum number are simply m is equal to minus 1 by 2 means here. So here 1 electron, here 3 electron, here 5 electron, here 7 electron. 1 plus 3 plus 5 plus 7 means how many here? 1 plus 3, 4, 4 plus 5, 9, 9 plus 7, 16 electron. For 16 electrons, we may get the quantum numbers as n is equal to 4 and m is equal to minus 1 by 2. So option 3 is the right answer. Balmer series of hydrogen atom corresponds to which spectral region? See, we know pretty well, whenever any electron gains energy, it will jump to the higher level. If the same electrons, when they come back to the ground state, the energy will be emitted. So in that aspect, emission spectrum will be observed here. In case of hydrogen, we do observe that emission spectrum. So in case of, if you observe the hydrogen spectrum, we will get different lines of, different series of lines here. So Balmer series, what are the various types of series, spectral lines formed in case of hydrogen spectrum means here. So here we may get here Lyman series, number 1 Lyman series, Balmer series. So when Lyman series, see, consider this n is equal to 1 means ground state here, ground state, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5 and n is equal to 6, like this, they are all 6. So when all will come back to when the electrons from other energy level levels will come back to ground state, then in that case which series is formed means here Lyman series is formed. When all come back to the first excitation state, nothing but here, when all come back to first excitation state, then which is formed means here Balmer series is formed. Like that we have Lyman series, Balmer series, Passion series, bracket series. So the spectral lines observed in hydrogen spectrum are simply they form some series here, Lyman series, Balmer series, Passion series and bracket series, and here fund series. See these here, these series, these spectral lines are obtained in generally here ultraviolet region. Balmer series are obtained in visible region. Passion series are obtained in infrared. Bracket series as well as fund series are obtained in far infrared. FIR means here far infrared region. So he asked about what? Simply Balmer series means here visible. Please, you try to remember the regions of various series here in hydrogen spectrum. So Lyman series is obtained in ultraviolet region, Balmer series is obtained in visible region, Passion series in infrared, bracket and fund series are in far infrared. Anyhow, he asked about Balmer series means here in visible region. The electronic configuration of copper atom violates which principle? Actually, if you write the electronic configuration for copper here, whose atomic number is 29, so we'll get here 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. Actually we will get here 4s2, 3p9, but what happened means here simply in order to get stability, copper does not possess this configuration, but it possesses the configuration of 4s1. So this is 3d, sir, 3d9 and 4s1 3d10. The actual electronic configuration of copper is what? 4s1 3d10. But according to the laws of electronic configuration, once the orbitals with least energy are completely filled with electron, then only the electrons have to enter the orbitals with more energy. If you compare 4s and 3d, 4s is having least energy than 3d. So after filling 4s with completely electron, then only the electrons have to enter 3D. But what is happening here? The second electron in 4s is leaving and entering into the 3D. So simply it is violating one of the laws of electronic convection, which is nothing but Haber principle. Why means Haber principle states that when the electrons are entering into the orbitals with the least energy should be filled with the electrons first. When the orbitals with least energy are completely filled with the electron, then only the electron should enter the orbitals with more energy. So strictly it is concluded that in case of copper, if you observe the configuration, so it is violating Haber principle, which means that the orbitals with the least energy should be occupied and completely filled with electrons, but without filling completely this 4s orbital, here the electron entered into 3D. That's why it is violating Haber principle. As compared to covalent compounds, ionic compounds generally have, generally when you compare this both to covalent as well as ionic bond is stronger than a covalent bond. So that ion cloud is more stronger than here covalent bond between the two atoms here. So the in general, due to the stronger ionic bond, so it is generally the ionic compounds contain but some larger melting points as well as the boiling point. Why? Because in order to have lower melting point, the bond should break easily, but here in case of ionic bond it's somehow difficult to break the bond. That's why here they contain higher melting points as well as the higher boiling points, whereas covalent compounds contain lower melting points as well as the lower boiling points. The octet rule is not valid for the molecule. See, if you consider carbon dioxide here, it is formed with one carbon atom and two oxygen atoms, so which is having a linear structure here. So here, if you write the configuration for carbon here, whose atomic number is 6, 1s2, 2s2, 2p2 here, the valency of carbon is 4. So carbon is having 4 electrons here, 4 electrons. So 1, 2. So 4 electron, 4 valence electron. For oxygen, for atomic oxygen is having atomic number 8 and its configuration is 1s2, 2s2, 2p4. So 6 electrons. So what happened here? So clearly 1, 2, 3, 4, 5, 6, and here also 1, 2, 3, 4, 5, 6. So here the carbon is sharing here. The carbon is sharing like this here. So as there are two electron pairs are shared. So what happened here? 2 electron pairs are shared like this, right? So carbon shades like this, please. Carbon shades 1, 2, 3, 4, 5, 6, 7, 8 here. So not like this. Then what happened? As a result here, we will get this shape here. And here CO2, like this, CO2 obeys octet rule, water obeys octet rule, and in case of carbon monoxide we may get but 3 bonds, 2 are simply covalent bond, and 1 bond is here. In case of carbon monoxide we are getting a triple bond here, and 2 are covalent bonds, 1 bond is coordinate bond, coordinate bond. Why coordinate bond is forming means oxygen is donating 1 electron pair to carbon, due to which one coordinate bond is formed. So anyway, it does not obey octet rule here. What is octet rule means here? Having 8 electrons in their outermost shell here. So carbon monoxide does not obey octet rule. 2 solutions of substance are mixed in the following manner here. 480 ml of 1.5 molar first solution, 520 ml of 1.2 molar second solution. What is the molarity of the final mixture? See here, for example here, assume here there is a solution here, first solution which is having molarity of V1 and volume of V1, and if it is mixed with another solution of molarity M2 and volume V2, then assume that here the resultant molarity is the capital M, and whatever volume here, volume is equal to V1 plus V2 only, clearly. Then what about the resultant? If these 2 solutions are mixed, then what about the molarity of the resultant solution? Means here directly we have an expression M is equal to M1 V1 plus M2 V2 divided by V1 plus V2. So what is molarity of the first solution here? Molarity of the first solution is 1.5 into V1 480 480 plus. Molarity of the second solution, what here? 1.2 into, what about its volume here? 520 divided by, what happened here? 480 plus 520. 480 plus 520 means 1000 only here. So what about 480 into, see, 480 into 15. So 1500, 15 8 120 here, 15 4 60 means here. So it is 720, clearly it is 720 plus, so 520 into 12, 12 0 0, 12 2 are 24, 12 5 are 60 plus 2, so it is 624 right here. So 624 divided by 1000, right, 1000. So what happened here? It is 720 plus 624, 4, 2 plus 2 4 is 1344, 1344 divided by 1000 means it is 1.344 molar. 1.344 molar. So option 4 is the right answer. To answer this question, you just remember this expression here. The molarity of the resultant solution is M1 V1 plus M2 V2 by V1 plus V2. The equivalent mass of H3PO4 in the following equation is clearly H3PO4. We need to find here equivalent mass of this one means here is equal to molar mass divided by molar mass. How can you find equivalent mass of a certain compound? Means its molar mass divided by, if it is acid, so basicity. What is basicity here? Basicity means here number of replaceable hydrogen atoms. Basicity means here number of hydrogen atoms replaced. Number of hydrogen atoms replaceable. Number of replaceable hydrogen atoms replaceable. So if you consider H3PO4 structure here, it contains this one here. So here this is OH, this is OH, this is H here. So this is H3PO4 here. So P right here. So what happened means here these two hydrogen atoms can be detached. These two hydrogen atoms can be detached here. And here this hydrogen which is directly attached to phosphorus cannot be detached here. So how many hydrogen atoms can be replaceable here? Only 2 atoms. So that's why here molar mass already given M by since we are capable of replacing only two hydrogen atoms, it is 2 basities. That's why phosphoric acid is what here? Dibasic acid. Phosphoric acid is dibasic acid. So here this one here, PO4 here, PO4 right? 1, 2, 3, 4 right? So dibasic acid. Dibasic acid, right? So here the equivalent mass of HCP4 is M by 2. Option 2 is the right answer. The normality of 4% NaOH. See, 4% clearly 4% mass by volume. Mass by volume means what? 4 grams of NaOH is present. 4 grams of NaOH is present in 100 ml of solution. 100 ml of solution, right? Then what about number of moles? Actually we know here normality. So what about normality here? Number of equivalents, gram equivalents. So normality is nothing but here normality. So number of gram equivalent divided by volume of the solution in liter. Volume of solution in liters. So gram equivalents. What are gram equivalents means what? 4 grams present. 4 grams present. Here 4 grams is present in sodium hydroxide means what about the molar mass of sodium hydroxide here? It is what here? 23 plus 16 plus 1 means here it is 40. So 4 by 40 divided by volume of the solution, but 100 ml here. You need to convert in terms of liters means 100 by 1000. So what happened here? 1 by 10 into, so this one. So 1 by 10 into 10 by 1 means here what happened? 1 normality. So 1 normal. So where it is it? So option 1. Which of the following cannot function as both Bronsted acid as well as the base here? We know here according to Bronsted-Lowry, according to Bronsted theory, what happened here? The substance which donates, proton means H plus is acid, which accepts the proton is simply, what is that here? Base. HCl, see, if you consider NHC, from NHC, see, NHC will act as acid as well as base. Why? Because NHC, according to Bronsted, we can add proton or we can remove the proton. If you remove the proton, what happens here? If you remove the proton, you will get NH2 minus. If you add the proton, what happens here? You will get what here? NH4 plus. So it will act as both Bronsted acid as well as base. Even HSO4 minus, you add proton, you are going to get what? If you add proton, you will get H2SO4. If you subtract the proton, you will get what here? Sulfate ion, SO4 minus 2. So it is acting both as acid as well as base, and even HSO4 minus, it is over right now. Then HCO3 minus means if proton is added, it becomes what? H2CO3, carbonic acid. If proton is subtracted, what happens here? If proton is subtracted, it becomes what else? Carbonate and CO3 minus 2. So all are acting as acid as well as base, but HCl, from HCl we can just remove the proton. So Cl, then we'll get proton, so then it becomes what is Cl minus. That's it. You cannot add proton here. So HCl acts as what? Only acid only. HCl acts as acid only. So here, which of the following cannot function as both Bronsted acid as well as base? Means here, since we are capable of removing proton from HCl, since we are failing to add proton to HCl, so the option is here, HCl is right answer. Which of the following will make a basic buffer solution? See, to make basic buffer solution, so how can we make a basic buffer solution? Means here, a basic buffer solution is obtained by adding a strong acid to weak base. So here, first of all, you pick the combination here. So clearly here, it's here. This is weak acid and strong base. So eliminated. Why? Because we need a weak base here. Why? Because for basic buffer solution, we need to add weak base plus strong acid. Weak base plus strong acid here. Strong acid. So this is eliminated. NaOH, strong base, again strong base, and this is what weak acid, eliminated. And here strong acid, weak base. Here also strong acid, weak base. But here the pH should be greater than 7 here. pH should be greater than 7. So here if you see this combination will provide us pH value greater than 7. That's why this one here catch. For basic buffer solution, pH value should be greater than 7. So if you compare these two here, this particular combination, why? Because here the volume of this base is more. So definitely this will provide us a pH value greater than 7. So option 1 is the right answer. Hydrogen gas is not liberated when the following metal is added to here. So here we have an obligation here. We have a query. Generally magnesium and zinc, generally they will try to chemically react with what? Hydrochloric acid here. So then after reacting with hydrochloric acid, they release hydrogen gas. But generally silver and copper, they won't show, they won't react easily with hydrochloric acid. That's why here, since they are unable to react with hydrochloric acid, hydrogen gas is not liberated actually. So option 3 or option 4 are right answer, but they has provided magnesium as Right answer. So here we have an obligation. We will see this one here. Magnesium plus hydrochloric acid means here MgCl2 plus MgCl2 plus H2. Similarly, zinc chloride plus H2, 2HCl, we balance here. And according to electrochemical series also, actually magnesium generally here silver and copper are not highly reactive metals when compared to magnesium and zinc. That's why they react with hydrochloric acid and they release hydrogen gas. But silver and copper simply in general they do not chemically react with hydrochloric acid. So according to the given question, either it is silver or copper, but in key is mentioned as magnesium. So definitely we'll go for what a query or obligation is one.